Hi, in this video we are going to discuss about performance matrix and basically how do we use confusion matrix to evaluate the performance of our model. The first thing that I want you to note is that the performance matrix is not actually matrix. Okay, it is matrix. That means units that we use. Okay, so it is not matrix. This was the confusion that I used to have, so that is why I'm clearing. Okay, so the matrix that we use to evaluate the model are these four things. So we have accuracy, precision, recall, and F1 score. Okay, so what is accuracy? Accuracy of a model, as the name can suggest, how many values are predicted correctly divided by the total number of values. Okay, so what are the values which are predicted correctly? They are true negative and true positive, right? True negative and true positive are the values that are predicted correctly. If this is the confusion matrix that we are taking in consideration, then the accuracy is going to be 50 plus 100 divided by total number of records, which comes out to be this particular expression. But the thing is, the accuracy is not considered as a good measure of performance, especially when the data is skewed towards one of the outcomes. Okay, so suppose your data is having 165 records and 160 of them are yes and only 5 are no. In such cases, accuracy is not going to be a good measure of performance. Okay, so for such cases we have F1 score, and to calculate F1 score we have two performance matrix, precision and recall. Okay, and we will talk about them very deeply. Okay, so we will talk about precision and recall here. The first thing that we will do, just calculate the accuracy real fast. ACCURACY. The accuracy is going to be true positive, true negative divided by total number of records. This is, by the way, the confusion matrix that we created in the previous video. Okay, so true negatives are 3 and true positive are 7, so it is 10 by 14. This is the accuracy of this model. Now we will talk about precision. What is precision? Okay, in the precision we talk about out of all the yes that we have predicted, how many are actually correct. Okay, so this is precision. We need to talk about how many of yes are actually correct. So we have true positive here, and how many are actually yes. We have true positive and false positive, right? False positive and true positive we have now. They are total number of yes, and how many of those yes are actually yes. And then we have recall. Recall says how many of the actual data set, in the actual data set, how many yes have been classified correctly. Okay, how many of the yes have been classified correctly. So the yes that have been classified correctly are given by true positive. How many yes are actually there in the actual data set are given by true positive plus false negative, right? The points that we have classified as no but are incorrect, that means they are yes in the actual data set, right? So this is precision and recall. Just remember, precision says what proportion of the positive identification that you have done are actually correct, and recall says what proportion of the actual positives have been identified correctly. Okay, just let it sink in, because it is going to make a lot of sense once you start visualizing it. And there are few points about precision and recall. The point is that the precision and recall both are very important metric while we are evaluating a performance of the model, but trying to improve the precision reduces recall and vice versa. And the other point is that we can increase or decrease these performance metrics by increasing or decreasing the classification threshold, which we are going to actually discuss in the next video, which is about ROC curve. Okay. Yes, so where were we? We were talking about the F1 score. Okay, so to calculate F1 score we had to calculate precision and recall, right? So since now we have precision and recall, F1 score is just harmonic mean of precision and recall. So this is F1 score, 2 into precision into recall divided by precision plus recall. And F1 score is actually a very better metric as compared to accuracy to evaluate a performance of a particular model. So this was about the performance matrix. In the next video, we are going to discuss about ROC curve, which is another way to evaluate the performance of the model.